and welcome to Master Talker online class. Today we'll be talking about a topic called elasticity. Okay, so you get your pen and paper and your notes. Let's write something. Okay, an elastic material can extend or compress when there's an applied force. If you bring a rubber and draw it, you apply a force, it can extend. If you bring a spring and press it, it can compress. So when such thing happens, you know that that material is an elastic material. Okay, so elasticity is the ability of an elastic material to return to its original shape and size when the applied force is removed. If you draw a rubber like this and leave it, it will come back to its original shape and size. So rubber is an elastic material. Okay, those materials that can return to their original shape and size when applied force is removed is called an elastic material. Example of an elastic material is what? Spring, string, rubber band, catapult, etc. Materials that can extend twice its original shape and size when an applied force, when a force is applied, is called an elastomer. If it can extend up to twice its original shape and size, you call that material what? An elastomer. Okay? Example of an elastomer is rubber band, catapult, etc. Now let's talk about Hooke's law. Hooke's law stated that provided that the elastic limit of an elastic material is not exceeded, that the force applied to an elastic material is directly proportional to the extension produced. Okay, so you can state it in another way, that what? That the force applied to an elastic material is directly proportional to the what? Extension produced, provided that the elastic limit of that elastic material is not exceeded. Okay, note that elastomers do not obey Hooke's law. Elastomers do not obey Hooke's law. So let us talk about Hooke's law mathematically. We say that the force applied, okay, is directly proportional to what? The extension. Okay, which means our F is directly proportional to what? Extension E. Now if we remove F, now we have that F is, if we remove the proportionality sign, we have that F is equal to what? Ke, where K is what? The constant. Okay, so if we make K subject of formula, we are going to have that divided by E. You have what? F over E. We can say it's equal to another F over E. Call this one F1 E1, F2 E2. This formula is very, very important. These two formulas, very, very important. Okay, we are going to use them in our calculation. Now, where our F is what? The applied force measured in Newton, and our E is what? The extension produced measured in what? In meters, and our K is what? Proportionality constant. If you don't want to call it proportionality constant, you can equally call it elastic constant or force constant. Okay, you can call it force constant. If you don't want to call it force constant, you can call it stiffness of material. The stiffness of the material. Now these names are very, very important, because in calculation they can ask you to calculate the stiffness of the material. You will not know that what? That the stiffness of material is simply to calculate K, and the SI unit, since this force is measured in Newton and this one is measured in what? And this one is measured in extension. So the SI unit is what? Newton per meter. Okay, Newton per meter, or like this, Newton per meter. So Newton is the one up, and meter, which is the extension, is the one down. So that is the SI unit of that. So let's take some questions. The first question, question number 1 said, a spring, okay, a spiral spring extends by 5 cm under a load of 60 Newton when the load is replaced by a steel block, comma, the new extension is 7 cm. Okay, then I say calculate the weight of the steel block. Okay, solution as simple as that. Just bring out your parameters and then you now know what to do. Okay, if we bring out our parameters, we have that the first force they gave us is the weight. The first force F1 they gave us is 60 Newton. Okay, and the first extension they gave us is what? 5 cm. No need to convert to meter since the other one is already in cm, so cm can cancel cm. So this is the first what? Extension. And the second extension they gave us is 7 cm, and now they are asking us what? The second force. They are asking us the second force, and we know that F1 over E1 is equal to what? F2 over what? E2. So let us substitute. 60 over what? 5 is equal to what? F2 over 7. So let's cross multiply. If you cross multiply, you have that F2 is equal to what? 60 times 7 divided by what? 5. You are going to have 84 Newton. As simple as that. So let's take the next question. It's very simple. So this is the simplest topic you can do in physics. So the next question said, question number 2. A 20 gram weight causes an extension of 0.72 cm in a spring. Calculate the extension by a load of 80 gram, assuming Hooke's law is obeyed. It's obeyed by the spring. Okay, solution. Very simple. Bring out your parameters. The first weight they gave us is same thing as force. Okay, and the force there, F1 is equal to what? 20 gram. In fact, no need to convert to Newton. Okay, because the other one is already in gram, so gram can cancel gram. Okay, so no need to convert in Newton. But if you like convert, it's waste of time, but you still get the same answer. The second force is equal to what? 80 gram. Okay, then the extension given, the first extension there is 0.72 cm, and they are now asking us of the second extension. So the same formula is applied. We know that F1 over E1 is equal to what? F2 over E2. So I have that 20 over what? 0.72 is equal to what? 80 over what? E2 that I'm looking for. If I cross multiply, I'm having 20 times E2 is equal to 80 times 0.72. Therefore, E2 is equal to 80 times 0.72 divided by what? 20. So what do I have? So if you do the maths, you're going to have okay, let's do the math together. So 0 will take care of 0. This into this is 4. So 4 times that. So 4 times 0.72. I'm having 2.8888 gram. Okay, 2.88 gram. Okay, so the next question. Now the next question said, okay, the next question said, now don't forget that extension, when something extended, is then as saying what? The length produced minus the original length. The length produced minus the original length, that is what? Extension. So please note that what? Extension is taken as saying what? The length produced minus what? The original length. Very, very important formula. Okay, so let's take a question. Very important. I have that what? With a mass of 25 gram hung from its end, comma, the total length of a spring is 15 cm. Okay, then I say when the mass is increased to 40 gram, comma, the total length of the string is 18 cm. Okay, now the first question say calculate the unstretched length of the spring. Number 2, the total length of the spring when it supports a mass of 15 gram. Okay, so very simple. So what do we do now? Solution. It's a very simple question. Solution. Now the first thing they say with a mass of, they've given us the first mass. The first mass is 25 what? Gram. Okay, with a mass of this hung from its end, the total length of a spring is 15 cm. So the total length, the first length I'm having is what? 20. The total length is what? Sorry, 15 cm. I'm having 15 cm. Okay, full stop. Now when a mass of 40 gram, they gave us another mass 40 gram, okay, is hung, the total length again L2 becomes 18 cm. Okay, but we know that what we are working with is extension, and extension 1 is equal to what? Original total length 1 minus the what? The original length. Extension 2 means what? Total length of 2 minus what? The original length again. So what do we have? We have that what? F, in fact let me use the mass, m1 over e1 is equal to what? m2 over e2. Okay, so let us now substitute our m1, which is the same thing as saying what? M1 all over L1 minus L0 is equal to what? M2 over L2 minus what? L0. Okay, remember that the L0 is the original length of that string. So what do we have now? Our M1 is what? 25 all over 15 minus L0 is equal to 40 over 18 minus L0. So let us cross multiply. If we cross multiply, we are going to have 25 bracket 18 minus L0 is equal to what? 40 bracket 15 minus L0. So let us clear. Let us multiply 25 times 18. I'm having 450 minus 25 L0 is equal to 40 times 15. 600 minus 40 L0. So let me collect like terms. If I collect like terms, I'm going to have that 40 L0 minus 25 L0 is equal to 600 minus 450. Okay, this one that is minus coming here became plus. This one that is plus going here become minus. So what do I have now? 25 minus this is 15. Okay, I'm having 15 L0 is equal to 600 minus 450. I'm having 150. Okay, so my original length is now 150 divided by 15, which is equal to what? 10 cm. So 10 cm is the original length of this particular what? This particular spring. So now the second question now said the second question said we should calculate the what? The total length of the string when it is now hung by this mass. So I'm still going to use that M1 all over L1 minus L0 is equal to what? M3 they gave us now all over what? L3 minus what? L0. Don't forget, okay? So what do we have now? This is 15, okay? So I'm going to say the same M1, which is what? 25 all over L1 is what? 15 minus 10 is equal to what? 15 they gave us as M3 all over the L3 there. We are looking for L3, the total length of this, minus what? Minus 10. So we can still cross multiply again to have that what? To have that 25. Okay, this is 25 over this minus this is giving me 5 is equal to what? 15 over L3 minus 10. So this can divide 1, this divide 5. So I can now cross multiply. If I cross multiply, I'm going to have that 5 bracket L3 minus 10 is equal to what? 15. If I divide everybody by 5, if you don't want to open bracket, this take care of this. L3 minus 10 is equal to what? 3. This one moving here. L3 is equal to 3 plus 10. So my L3 is equal to what? 13 cm. So this is the total length when a mass of 15 gram is hung on that spring. Okay, so the next question. Okay, let me be reading it out, okay, as you write. An elastic string stretches to a total length of 30 cm. Okay, they gave us the first length here now. 30 cm, okay? When a load of 500 Newton, they gave us force now. Force is taken as load, which is what? 500 Newton, okay? With an additional load of 100 Newton. So which means this is F1. F2 they gave us now. This one was still there before they put another 100, which is what? 500 plus that 100. So the additional, the second load now is now what? 600 Newton, okay? With an additional load of 100 Newton, the string stretches by a further 2 cm. The string stretches by a further 2 cm, which is the extension. Okay, the extension there. This one, and they gave us extension here to be what? 2 cm. Okay, then calculate the original length of that string. Calculate the original length of that string. Okay, I can use my formula that said F1 over E1 is equal to what? F2 over E2. Okay, let me get my E1 first. If I substitute, I'm going to have that 500 all over E1 is equal to what? 600 over 2. Okay, 0 can cancel 0, 0 can cancel 0, or you do cross multiply if you don't understand this pattern. 2 here 1, 2 here 3. So I'm having that what? 3E1 is equal to 5. So my E1 is equal to what? 5 over 3. Okay, my E1 is 5 over 3. Okay, okay, they said 3C under a load of 500 with an additional load of 100 Newton. Okay, okay, so 5 over 3 is the extension, and I know that formula for extension is equal to what? The length minus what? The original length. The length produced minus the original length. Okay, so I'm having that 5 over 3 is equal to what? 30 minus L0. So I'm having that what? This one going here, this one come here. So L0 is equal to 30 minus 5 over 3. So L0 is now what? 3. 90 minus 5, which is what? 85 over 3. Okay, cm. Okay, so the next question, let's take the next question. With an additional load of 100 Newton, it now extends okay, we still have time, so let's go to the next question. The next question said a string. The next question said that a string has a total length of 7.5 cm. The length of that string, that is the original length of this string, is 7.5 cm. Okay, has a total length of 7.5 cm. Okay, under a load of this. So they gave us mass under a load of 250 Newton. So the mass there is 250 grams. Sorry, not Newton. 250 grams. Okay, so and the total length it has, which is L1, when this thing is on it. Okay, and even they did not say that this thing is on it, we now know that this is the original length. So he said it has a total length of 7.5 cm under a load of 250 grams and 20 cm under a load of 300. So the second length now is what? 20 cm. Okay, under a load of 300. So the mass now is now 300 gram. Okay, then I say calculate the extension of the string per unit load. Extension of the string per unit load. That is I question. Extension of the string per unit load. Then I said the force constant of the string. The force constant of the string. So we need the extension to get the original length. Okay, extension per unit load. Okay, extension per unit. So we need the extension. Okay, since we need the extension, we know that what do I say? M1, this is M1 and M2. M1 all over what am I saying? M1 all over L2 minus L1 minus L0. I hope you know this is the extension. L1 minus L0 is equal to what? M2 all over L2 minus L0. Let us get the original length of this man. So what do we have now? We have 250 all over 7.5 minus L0 is equal to what? 300 all over 20 minus L0. So 0 can cancel 0. 5 here is 5. 5 here is 6. Okay, so I'm having cross multiply now. I'm having 5 in bracket of 20 minus L0 is equal to 6 in bracket of 7.5 minus L0. So what do we have now? This is 100 minus 5 L0. 100 minus 5 L0 is equal to 7.5 times 6. I'm having 45 minus 6 L0. Okay, so collect item. This one go here, this one come here. Okay, that is, sorry, 17.5. It's a mistake. 17.5, please. 17.5. 17.5. 17.5. Sorry. Is so 17.5. So I'll have 17.5 times 6. So I'm having 105. Okay, so this is 105 minus 6 L0. So collect items to have that 6 L0 minus 5 L0 is equal to 105 minus 100. So L0 is equal to what? 5 cm. So this is what? The original length of this man. So to calculate the extension, now, the extension is going to be what? L1 minus L0, which is what? Or L2 minus L0, depending on the one you want. The extension. So what do we have now? Extension there. Okay, let me write it here. Okay, the extension is equal to what? L1 minus L0. The first extension, when that one is hung, it should be equal to what? 17.5 minus 5. So what do I have now? That is 12.5 cm. Okay, so this is the extension. But extension per unit load, which is E1 over L1, extension per unit load, that is extension over load, which is what? The extension there is 12.5 divided by the load I'm using now is in fact, we need to convert this thing because they are talking about load, so we can convert. But if we don't want to convert, if we want to use extension, okay, they said load. So since they said load, we have to convert. Let's convert this one to meter. If we convert this one to meter, we know that 100 cm is equal to 1 meter. So 12.5 cm is equal to x meter. So if I cross multiply to get my this thing in meter, I'm going to have 100x is equal to 12.5. So x is now 12.5 divided by 100. So what do I have? 0.125 meters. Okay, so to convert the other one to newton, to a load, will now be what? Load is equal to what? Mass times acceleration due to gravity, and the mass there must be in kilogram. So we have that. How do you convert it to kilogram? Can I clean here? Yes. So let's convert it to kilogram. I know that 1000 gram is equal to 1 kilogram. Okay, so let's use this one. 250 gram is equal to what? S kilogram. So I'm going to have cross multiply. 1000x is equal to what? 250. So therefore x will now be 250 divided by 1000. So what do you do? To convert the mass to kilogram, that is what I'm doing. So 0 into 0, 1, 2, which is what? 0.25 kilogram. So I'm having 0.25 times 10, which is acceleration due to gravity, which is what? 2.5 newton. So extension over original length, sorry, overload, extension overload or force. Let me use force since I've used the other one as length. Extension over force should be what? You know, force is same as load. Extension 0.125 divided by the load 2.5. So what do you have? You are going to have 0.125 divided by 2.5. So I'm having 0.05 meter per Newton, because meter is up and the force is down. Meter per Newton. Okay, so that is that. Now the second thing they say we should calculate is the force constant. And you know what force constant is? Force constant is what? My force constant is equal to what? K. And K is what? F over what? E. So turn this one around, it's going to be what? 2.5 divided by 0.125. So you are going to have 2.5 divided by 0.125. So I'm having 20 in what? Newton per meter. Okay, in Newton per meter. So let us solve the next example, or maybe in our next class. Let me check my time. Okay, thank you very much for watching. Please subscribe. In our next class we'll continue with some terms in elasticity.